Hello. We'll start in a minute here. Let me get myself set up. Alright, we're going to start by looking at yesterday's, what I asked you to do yesterday. Yesterday you were to graph. And I'm not collecting it, but please check your graphs to see if they match mine, and I will walk you through each of these. So number one was y equals x plus 4. When it comes to graphing things, you probably want a coordinate plane. Is that the right one? Yeah. You're going to want a coordinate plane, so you can go ahead and make yourself a coordinate plane. I made one right there, off to the side. I'm not exactly, well, I know where this is going to be and what it's going to look like, but when you're first starting off, you probably aren't familiar quite with this, and you might not know how to graph. I told you before that these are all linear graphs, which means they are lines. And when it comes to graphing a line, you need one of two conditions. You either need 2 points, or you need 1 point and slope, which we haven't talked about slope very much yet, so you're going to be doing it this way. We just need 2 points that make this true. So what you're going to do is you're going to make an XY table for these. So you should have a table written somewhere. And this is your function. Okay, so your function is a machine. Its rules is take x and add 4 to it. So your input goes in, x goes in, x, you add 4 to it, and out comes your y put, which is y, which is the same thing as f of x. So these are interchangeable terms. So x goes in, y comes out. So you're going to sit here and you're going to choose some numbers to put in. It does not matter what numbers to put in here. I did not restrict your domain, or I did not tell you, hey, you cannot use certain numbers. So it's going to be implied that you can use any number you want. So you're going to pick numbers that make sense to you, probably. The easiest one that I suggest everybody pick every time is 0. So what happens when I put in 0 for x? If I make x 0, my function says I need to add 4 to it. So I'm going to come over here, I'll rewrite it, so it's going to be y equals 0 plus 4. Well, what does y equal? In that case, it equals 4, so then I'm going to get 4. This here is your first coordinate pair. So once you have this ordered pair, you can go ahead and plot it on your graph, 0, 4. That's 0 on the x and 4 on the y, so you should have a dot here. Again, if you didn't pick 0, then your dot might be somewhere else, but no matter what numbers you chose, you're still going to get the same line. So double check to make sure your line matches mine. And again, you could have picked any other number you wanted. 0 is just the easiest to work with. Let's pick another one. Maybe we picked 2. I don't know, maybe you picked -2. Maybe you picked 3. Maybe you picked 1. 1 is probably another easy one to do. I highly suggest you use 0s and 1s for these, but I'm going to use 2 just to give myself a little more room here because I know what it's going to look like. In this case, I'm going to plug in 2 for x, so y equals 2 plus 4. And our function tells us whatever our input is, y will be our output. Here our input is 2. And again, I picked it. You could pick any number you wanted. Throw it in there. 2 plus 4 gives me 6. So my output should be 6. And there's my next ordered pair, which is 2, 6. So I'm going to come over 2 on the x, 6 on the y, and I got 2, 6. And then you're going to go ahead and draw your line the best you can. I highly suggest you use rulers when it comes to drawing lines, but your line should look like that. Your line has arrows on the end of it because it goes on forever, so don't forget your arrows. I guess that one's kind of far down. I don't need all of them. I'll erase that part. So there's your line. This here is the graph of the function x plus 4. So this line here equals, I guess we used y. Y equals x plus 4. And that's what you should have written. Wouldn't you get yes every time if you put in a different input? You'd get y every time. It depends on the input, right? So let's say I put in 3. Then it would be 3 plus 4, and y would equal 7. So my point is 3, 7. I can come over here 3 and then 7. Hey, look, that's on my line. So I already know that's on there. If I plugged in -2, then I get -2 plus 4, which is -2. I'm sorry, not -2, -6. Right? -2 plus 4. That gives me -2 as well. That gives me +2. Sorry. It gives me +2. My integers are off today. And then 2, and then +2 is up here. So that's still on my line. Okay, when it won't be a function. That goes to your definition. How come that didn't delete? That's in a different line. That goes by your definition of a function. Function. Every x has exactly 1 y. If this is true, then it's a function. So every x value, if it has exactly 1 y, then it'll be a function. For example, I guess in the book it gave you problems like it gave you a table of values, so x and y. And again, you're just going back to this definition. Every x has exactly 1 y. So if this was 1 and this gave you 2, and this was 1 and this gave you 3, then this 1, this x value of 1, has more than 1 y. So this is not a function. However, you are allowed to have more than 1 y for different x's. So if x was 3, y equals 2. If x was 4, y equals 2. If x was 5, y. This is a function. right? As long as every x has exactly one y, it's a function. In this case, your function would be something like y equals 2. So when you plug in x, well, I don't have any x. X goes in and 2 comes out. And then you can graph that too. It's just going to be a horizontal line. Which I can graph one like that. Let's graph a function where f of x equals 3. In this case, it's just saying y equals 3. So on your coordinate plane, you can pick any value you want, which is like 0. Well, y equals 3. If x is 0, y still equals 3, so y equals 3. Maybe 5. Well, y equals 3. If x is 5, y still equals 3, so it's 3. You just get a horizontal line here, though. So in this case, 0, 5, I'm sorry, 0, 3, and 5, 3. You'll notice just a horizontal line there. And that gives you your horizontal line. And any x value you have is there. And that still passes your vertical line test. You'll see how every time it has the line. That still passes. However, if I switched it up, if I did the inverse of this, which would be x equals 3, it's not going to work. X equals 3 is not a function. In this case, it's a vertical line. So, right, x, I can only put in one value, which is 3. And I will get out any value I want over here for y. It'll get every value possible here because there is no y thing. So y would equal 1, 2, 3, 4, 5, and so on. And that would give you a vertical line, which is going to be on this point here. Right, any line there, which I want the ruler for it. If this is going to cooperate, it doesn't like me. Yeah, it doesn't like going that small, but that would give you your vertical line. If I can get it lined up good. That gives you your vertical line. Yeah, we'll do some today. We're just going to be doing drill line graphing. I wanted to go over your homework from yesterday, or your work from yesterday, and make sure you got that right. So I did the first one. Let's look at the next one. Again, you're going to need a coordinate plane for things. And number 2 on your homework was y equals 2x. Same deal. You're just going to make an xy table, pick some values. 0 and 1 are probably the easiest to do, and plug it in. So then 2 times 0 gives you 0, so you know you have a dot here. 2 times 1 gives you 2, so you know you have a dot, 1, 2. And again, they are all linear, so once you have 2, you can connect your dots the best you can. My ruler doesn't like being this small. It should look like that. And don't forget, lines have arrows on both sides, so your graph should look like that. Number 3, I'll do in blue. No, I don't want to erase anything. And this says f of x equals 3x minus 4. In that case, again, xy table. Pick some values. Again, 0 and 1 are probably the easiest. 0 times 3 is 0. That gives you negative 4. 0 minus 4 is negative 4. 1 times 3 is 3. 3 minus 4 gives you negative 1. So there's those values. If you don't like the negative numbers, pick bigger numbers. Like if you wanted to pick 2 or something, 2 times that is 6. 6 minus that gives you 2. Any of these dots will work. So 0 and negative 4 is going to be right. Sorry. right here. I should get rid of that. 0, -4 is here, and 2, 2 is here. So in this case, your line is there. Looks like that. And again, it has arrows to go that way. Number 4 I'll do in red. 4 was f of x equals -2x plus 1. Again, just make your xy table. You only need 2 values. Let's pick -2 and -6. Again, you could have picked anything you wanted. 0 and 1 are always great numbers to work with. But this is a negative number, so if I pick negative numbers, it's going to make it positive. So I'll work with that. So -2 times -2 gives me +4, plus 1 gives me 5. So -2 and 5 is right here. And -6 times 2 is 12, plus 1 is 13. So then -6 and 13 is up here. And you'll note that this one here goes in the opposite slope direction. We have negative slope here. But this here is our line. Like that. So those are your 3, or well, those are 2, 3, and 4. Okay. Try to get all work done by Friday. I understand people have strange schedules these days. It might be hard to get some work in some days, but try by Friday to get things in. We can look at our homework. Our homework isn't too bad. Again, I'm not collecting the graphs you make. I'm hoping you're making the right graphs. I should have just checked the works you did there. But your homework is page, let's go back to black, is page 408, 12 to 26. So let's look at 12 first and give you a section there, and then I'll do one from 21 to 26 for Johnny there, once I find it. So first off, you're going to graph the equations, and we're going to say if they are functions or not. So y equals x minus 3. This is going to be a function because every input is going to get a different output. Like if I put in 0, I get -3. If I put in 1, I get -2. If I put in 2, I get -1. If I put in 3, I get 0. So you could pick any one you want to do it. Find your coordinate plane, plot them. So 0, 3 is here. Oh, I'm sorry, that's -3. 0, -3 is down here. 3 and 0 is here. This here is my line. Again, you only need 2. They might be too close. Yeah, they're too. I might be able to squeeze it in there. Yeah, good enough. Right, there's your line. And you get your arrows. So that would be 12. Again, just plug it in and do it. You'll note this does pass your vertical line test, so it is a function. So once you graph it, you should be able to see vertical line test should tell you if it's a function as well. But you should also note that, hey, this is going to be a line just because it looks like every other line that you're going to do. So 12, what I want from you is to tell me if it's a function or not, and look at it. If you get to things like the ones where x equals something, those are the ones that aren't functions. So 18, here you have x equals 7. So the only x values you can plug in here are 7, and your y values will still give you everything you can. So 1, 2, 3, 4, right? And you'll note that, hey, we have multiple things here. And this is a vertical line at x equals 7 is the other way to look at it. Like, hey, x equals 7, so this is a vertical line here. Right, so you're going to get all these points here. You'll see how it's being vertical. Vertical lines will not pass your vertical line test, and therefore are not functions. Yeah, just put the equation and graph the rest. So let's look at, actually, let's get rid of everything. So let's look at 21. 21, it wants you first to solve for y. Was y equals 16. Solve each equation for y and then graph. Yeah, so you want to solve it for y. So this is similar to how you were solving formulas beforehand. We want to get y by itself. So what you're going to do is you're going to get rid of everything that's attached to it. So over here we have this negative 4x attached to it. So we're going to add 4x to both sides. Let's do plus 4x to this side and plus 4x to this side, and you're going to get y equals 16 plus 4x. You probably want to rewrite that, so it's 4x plus 16, just to get it in more of a standard form. And then you would go ahead and graph this. So this is what you turn into me, and then you can graph it, and we can graph that easily. Again, we're going to pick xy values. Let's pick negative 4, because negative 4 times 4 gives you negative 16, and that will give you 0. So negative 4 and 0 is 1, which is right there. And let's go ahead and pick 0, because 0 times 4 is 0, and 0 plus 4 will give you 16. So 0 and 16 up there. And again, you only need the 2 points to get a line. So there's your line. Is 22 y equals x? I don't know. Let's go ahead and do it. I don't think so off the top of my head. I don't think that's going to cancel out. Just watch your... Oh, that's because I can't. Watch your division with that one. So we have negative 3y equals 3x minus 9. We want to get y by itself. So here you're multiplying. So you want to divide this by negative 3. But you're dividing the whole thing here by negative 3. So be careful with that. This is going to cancel, leave you with y. And then if you want to look at this as 3x divided by 3 minus 9 divided by 3, you can. Just make sure you're doing each term by 3, by the negative 3, sorry. So in that case, you're going to get y equals negative x, and then this is already negative, so this is going to be positive 3. 9 divided by 3 gives you 3. And then this here is what you would graph. Which in that case, you should note your x value is negative, so your line should be going in this direction. Just get you to start thinking that way. Let's see, what do I want to put in? I'll put in 0, and I'll put in negative 1. Again, the negative 1 is going to make this a positive 1, and then plus 3 gives you 4, just to make your integer work better. And then 0 is just going to cancel that out and give you 3. So 0 and 3. It's right there. Negative 1 and 4 is right there, and then your line is... My roller's not going to like that, but it's okay. The slope is 1, so it goes like this. And then looks like that. And again, this is what I want to see for it. Number 21, times 221. Going to be negative 4x plus 16. 21. No, because it starts off as negative 4x. So Johnny, gotta get rid of my layers. For 21, it starts off as negative 4x plus y equals 16. And I'm moving this whole thing over. And this is being added and subtracted, so I add 4x to that side. And I add 4x to this side. And again, you can't do anything with the term, it just gets tacked on. So over here it gets canceled out, so you get y equals 16 plus 4x. And if you want to leave it like that, you can. But I mean, it's just nicer to see it written this way. So just watch it. When you do adding and subtracting, you're subtracting 4x here. It's a minus 4x. So you have to add it to both sides to get rid of it. You gotta do the inverse there. And this plus sign stays with the y. But we don't write it because you don't need it. Does anybody want me to do another one for you? Just practice graphing. We're going to practice this more tomorrow, probably. Just because we need to get really good at it before we can move on. I don't know if there's any other hard ones. The decimal one, just be smart when you pick your, like 24, be smart when you pick your x values. Y minus 6 equals 0.5x. Just be smart when you pick your x value. Can't you make that? No, you cannot combine those terms. You are not multiplying them, you are adding them. So what was it, y equals 16 plus 4x. This term and this term are not like terms. They do not have the same variables. You cannot combine them. However, if this was equals 16 times 4x, you can combine them by doing 4 times 16. But it's not. A good way to remember that is that you have to add and subtract like things. Like you have to add apples to apples, oranges to oranges. You have to add x's to x's. This doesn't have an x, so you can't add it to your x's. But they have to be like terms to combine. For 24, this is your problem. I'm actually going to rewrite this. I mean, you can use it as a decimal, but I'm going to rewrite it as a fraction to help you with fractions a bit. But this is just 1/2 x, right? Again, same kind of deal with getting y by itself. You're going to add 6 to both sides. You cannot combine that because they aren't like terms. So this is just going to be y equals 1/2 of x plus 6. In here, when you pick your x, y terms, if you pick multiples of your denominator, it makes your math easy. So pick multiples of denominators. Right, if I were to pick like 5, that's a pain because now I got to do 1/2 of 5, which is 2.5 plus 6, which gives me 8.5, and now I have to graph y on 8.5, which really isn't that bad, but if this was like a 4 or something, then it would be even worse. But if you picked multiples of the 2, so like if you pick 2 for it, 1/2 of 2 is just 1, 1 plus 6 is 7. Right? If you picked 4, 1/2 of 4 is 2, 2 plus 6 is 8. right? You get nice round numbers. So when it comes to fractions like that, I'll show you with an ugly one. Maybe you pick, and this isn't one of your problems, so I'll just make it one. Maybe you just have y equals, I don't know, 3/8 x plus 4, right? What x values do you want to pick? Again, you want to pick multiples of that denominator. So first off, 0 is a great one to do because that's going to cancel out that fraction and just give you 4. In your second one, you probably want to pick 8 because times 8 over, what is it, 1 equals 3. It's just going to cancel those out. And then 3 plus 4 gives you 7. So you get nice values for them if you pick your multiples of your denominator. The other one would be 16. 16 would be a great one to pick because then you're going to get 3/8 times 16 over 1, and these will cancel out 1 and 2, and you get 6. Then plus 4, so you get 10. It's just easier to work with if you pick multiples of your denominator. So just a tip. I don't think there's any problems like that, but it's an option for you. Are there any other questions? Again, it's just graphing and then, well, manipulating the equation, doing the graph. Hopefully you're doing the graphs all right. Again, it might be a little tough. Let me, I don't know if you have a calculator like this or not. If you have a calculator like this, you can graph them too. Right? For example, you had y equals x minus 3. You just hit your y equals button if it's going to work. Is this one going to work? Let me bring up a new calculator. See if it'll like that one better. Hit your y equals button, then you can just type in x, which is this xt theta n button, minus 3, and hit graph, and it actually draws you that line for you. So you can do them that way. And they can get fancy too. Right. So that's one way to check them if you already have them. But it sets it up so it has to be y equals something. So you can't plug in, right? You can't just plug in negative 4x plus y equals 16. You actually have to plug in the 16 plus 4x and graph it that way. And that should be your graph for that. And it looks similar to what ours is. It might be off the window and you might have to play with your window functions here. But you can do it with the calculator too. With that kind of calculator at least. That's nice for checking answers and stuff. With that, if you have any further questions, send me an email. If not, we'll talk tomorrow. So long. Bye.